So our final speaker today is Sai Avuthu. That was pretty close, from Eaton, who's going to talk about direct printing of power modules using advanced 3D metal printing and screen printing. Thank you.
Hello, everybody. I know I'm the last speaker before lunch. I'll try not to hold you for the lunch, and I don't have snacks. So coming to the presentation, first I'll talk about a brief introduction about the Eaton, and I'll give a very high overview of the power module itself, and I'll dive into our two-day module which we built as a proof of concept, and then I'll provide details on the high-performance power module. So in terms of who Eaton is, we advertise ourselves as an intelligent power management company, and we operate more than 170 countries with the annual sales of around $23 billion. And we make wide range of products, anything from EV chargers to golf grips. So you could see the diversity there. And in terms of the operation, we operate in two main divisions, electrical and industrial. In terms of for me, I work closely I work in Eaton Research Labs, which comes under corporate, and we work with almost every branch of that you're seeing on the screen. So in terms of the Eaton research itself, this is the core research. I'm not going to go deep into everything. I work in the advanced materials and processes, and I lead the printed electronics initiative for Eaton. And coming to today's topic, it's about the power module. At 80,000 level details, power modules are typically used to convert DC to AC. So typically it's done using etched copper on a ceramic substrate, and here our goal is to achieve that using printed electronics. So typically power modules, I've shown the couple of pictures of the power modules here, and they're also made using the silicon IGBT as a technology. And the industry is currently moving into the silicon carbide, so we choose silicon carbide, and the reasons are, for the silicon IGBT, there's typically 2 dies that needs to be attached. Compared to the silicon carbide, it's only 1 die, and the die size is also reduced by almost 3 times. And hence we choose the silicon carbide technology and implement the power module concept using the printed electronics and metal printing. So I listed some of the CTQs that we used in order to develop the module. So first we wanted to develop a very high power module. We wanted to operate around 200 kilowatts to 250 kilowatts. And for that we need a better heat exchange. So every time when we are trying to do the electronics, we always think about only the electrical resistance. So while developing the power module, we learned that the thermal conductance or the thermal resistance is also very important for heat exchange. So we wanted to implement a direct cooling concept where we took our challenge as 100 watts per die as a thermal loss with a delta T of 80 degrees Celsius. And since we are printing, we would like to include more electronics into the power module. For instance, we would like to include sensors directly into the power module, and also the gate resistors and active cooling system. And these modules are operating at 800 volts, so we wanted to have at least 1200 volts dielectric insulation. And these modules are meant to operate at around 200 kilowatts to 250 kilowatts, so hence we need a high current capability. And we are talking here about 200 to 250 amps of current. So coming into the design, obviously we wanted to do the integrated design, and we wanted to make most of the module using the printing. So first we partnered externally in order to print the heat exchanger using a ceramic. What we learned is, for a given material, it's a typical way of fabrication, bringing it to the printing part of it. The thermal conductivity increases by 20%. That's because with printing we were able to achieve the shapes and structures that traditionally not possible. And we would also like to, as I mentioned before, we'd also wanted to include as much as electronics into the module. So we were talking about adding the resistors, capacitance, and here we are talking about the high density capacitance into the module. and